Well, the screen is yours.
My name's Geraint Chaffey from KU Leuven, the University of Leuven in Belgium. My research interests are in HVDC protection systems, and today we'll be talking about the harmonization activity we've been working on within the protection system related work packages within the promotion project. First, very briefly, why HVDC protection? Well, clearly there's an ever increasing interest in multi-terminal VSC HVDC systems, and 5 or 10 years ago there were many challenges before we could implement such a system, but clearly, as many of you know, there's been many developments in recent years, including high power testing of HVDC circuit breakers, for example, that within the promotion projects, which we'll hear more about later. But also other R&D and overall protection systems, protection strategies, protection IEDs, and various other devices. And of course, there are many different concepts, as you see at the top right of the screen here. But now, of course, we're also seeing the first multi-terminal VSC HVDC systems demonstrated with multi-gigawatt systems, the Zhangbei project here in China, to be operational this year, which is clearly very exciting. So why harmonization and why now? Well, clearly there's rapidly developing technology for multi-terminal HVDC systems, but the existing systems are typically manufactured or at least coordinated by a single organization, and whereas future large-scale HVDC systems has to be multi-vendor. And if we have such a multi-vendor system, it's really attractive to have harmonization for a wide range of aspects, functional requirements, test procedures, terminology, system design, and many others. And there are many advantages to harmonization, yet there are still many identified gaps in harmonization in HVDC protection and HVDC systems in general, I think, for meshed multi-terminal grids. So one of the aims of the promotion project is to contribute the outcomes of the technical activities within the technical work packages to harmonization and standardization. So just a brief overview of the harmonization activity within promotion. As Paul already mentioned, there's various technical work packages looking at various different aspects, looking at, for example, the control, the protection of HVDC grids, including DC circuit breakers, HVDC GIS. This presentation will cover the protection systems, that is the protection system design, the modeling, perhaps the secondary systems, the protection relay or IED, and then the following presentations will cover DC circuit breakers and GIS. And also, as Paul mentioned, there were more presentations on Friday looking more into the control and wind aspects. So focusing on the protection systems, just a very brief introduction to the technical topics that will be covered we're still covering within the promotion project. Focusing on our two technical work packages, looking at the development of HVDC protection systems and also the demonstration of HVDC protection systems with a wide range of technical topics, looking at the functional requirements, the specification, the development and the comparison of HVDC protection methodologies, also protection IED prototypes, and then looking at cost benefit analysis and taking that work into a demonstration where we're looking at a slightly more realistic environment and looking to demonstrate HVDC protection systems. It's not the intention of this presentation today to look into the detailed technical topics, but only here to say that we've covered a wide range of technical topics, and then from these technical topics we think it's of interest to present some harmonization activities based on the research that we performed. If you're interested in any of these technical topics, please let me know and I can point you towards the right references and people to talk to. But then today, in the harmonization topics that we're interested in from these HVDC protection system topics, there's been a range of activities within our technical work packages which we think are of interest for future harmonization, and we have contributions or planned contributions to harmonization or pre-harmonization activities in CGRE B4, CGRE B5, IEC TC 95 and the IEEE Standards Association. Today I'll briefly present a summary of 7 different topics where contributions to harmonization bodies have either been made or proposed. looking at design of protection systems, application and specification of HVDC circuit breakers, performance evaluation of protection systems, communication protocols and communication interfaces for protection systems and devices, and functional testing and specification of protection relays or IEDs, and modeling of DC circuit breakers. Just a brief summary of each of these topics then. First, looking at the design of protection systems, and depending on how you design a protection system, you can get different benefits. The protection system design is a trade-off between various different aspects, including the equipment that you use, the protection strategy and control used, perhaps you could say philosophy, but also system impact, maturity and cost. And there are various other considerations. From the work we presented in the technical work packages, we think there's various key considerations which could be useful for future harmonization, including the classification of various aspects, the fault clearing strategies, the protection algorithms, also the work where we presented protection algorithms and the associated IED requirements and activities. Also the definition of the concepts and terminologies, not just for the protection system design in terms of the selectivity, for example, of the protection system, but also the equipment rating and the interfaces. Also our work thinking towards multivendor interoperability and the impact of the protection system on cable over voltage requirements. And this work has already been presented to several different CGRE working groups, and we hope this will be taken into account in their work. The next topic, application and specification of HVDC circuit breakers. Depending on the application and, for example, the protection strategy, the grounding and the faults which you would protect against in a protection system, there are quite different requirements on the HVDC circuit breaker. And the work presented in the technical work packages in promotion has shown that there are several different scenarios that you might want to use distinct circuit breaker configurations or types for on an HVDC system. And each scenario has different implications in operation speed, current rating, energy dissipation, for example. And it's proposed that this sort of classification could be useful to rate circuit breakers in future HVDC systems. This work has already been presented to a CGRE working group on HVDC circuit breakers. Next, looking at the performance evaluation of HVDC protection systems. So within the comparison, or within the protection work, we've developed many different protection strategy configurations with different pieces of equipment and different protection philosophies. And there was a need to have a fair way, a common metric of comparison by which we compare these different protection strategies. And for this reason, key performance indicators have been developed in order to compare different protection strategies and different implementations of protection strategies. And you can see the wide range of key performance indicators that we've developed here, from effectiveness indicators, for example, power restoration time, to failure indicators indicating how the likelihood of failure of different protection strategies and different protection sequences, and also looking towards economic indicators in addition. And this work is going to be proposed towards a new IEC working group. Next, looking at substation communication protocols for HVDC protection systems. Within the protection work we've been looking at within the project, there's been quite some work into HVDC protection IED prototypes, including thinking about how they might want to communicate in a future HVDC substation. And although there are many different protocols which could be used for an existing AC substation, not all of these protocols are applicable for all applications in HVDC, particularly when we're talking about protection. We require very fast communications because we require very fast actions. And so some part of the work performed within the promotion project has been looking at the communication standards and looking at the trade-offs and limitations of existing communication standards, and the work presented in this contribution focuses around a set of possible candidates for fast, reliable and deterministic substation communication, particularly for multivendor and multiterminal HVDC protection. And it's proposed that this sort of work should be taken forward by a standardization or harmonization body in order to properly or more fully investigate the future requirements for HVDC substation communication. It's proposed that this work will be proposed to an IEC working group or technical committee and a CGRA study committee. Next, looking at the communication interfaces between the HVDC protection devices. When we're looking towards multi-vendor HVDC protection systems, of course, we need interfaces between different protection components, for example, protection IEDs, HVDC circuit breakers, but also between different IEDs and the IEDs and the converter stations, for example. And so we need strong harmonization in order to define the functional requirements and the specifications of these interfaces between these different devices. So the work presented within the project is focused on the interfaces between the protection IEDs and between the protection IED and the circuit breaker. And here we look at the interfaces that are required for basic operation. For example, the trip signal between the protection IED and the circuit breaker, and also the circuit breaker functions, which might be optional and not applicable to every protection system or every circuit breaker. For example, current limiting on a circuit breaker, which might not be possible for every topology. So it's proposed that this similar interfaces might be used in a future HVDC system, and that's why this has been presented already to a CGRA working group on HVDC circuit breakers. The next topic, looking at the specification and functional testing of HVDC protection IEDs. So unlike for AC protection IEDs, there aren't functional requirements or functional test procedures for HVDC protection IEDs. And therefore, when we were developing the protection IEDs in the project, we also needed to develop methods by which we could test the functional performance of these protection devices. And so these test procedures are testing for basic characteristic accuracy and dynamic performance. And this testing has been performed with standalone tests, just testing the properties of the individual device, and also some system level tests evaluating the performance in an overall system. And it's proposed that these sorts of tests might be useful for future HVDC systems. And this has been proposed to several harmonization bodies, IEC TC95, IEEE Standards Association P2004, and also planned to be contributed towards CGRA B5. And the last topic I want to mention briefly today is looking at the approach to modeling of HVDC circuit breakers. The work within the promotion project within Work Package 6 has looked at the modeling of different circuit breaker technologies, and the developed models can represent various different configurations, including the IGBT and the thyristor-based hybrid circuit breaker, the mechanical circuit breaker, and the VSC-assisted resonant circuit breaker. And there have been several different complexities of circuit breaker model developed, both detailed model for DC circuit breaker level studies and also simplified models which are more suited but still representative for system level studies. Importantly, here we have common modeling formats, interfaces, and common modeling verification approaches, and it's proposed that these should be useful for future designers and operators. Also notable that it's planned to release open source models for these circuit breaker models. And I understand that these models will already be used in a CGRA working group on DC circuit breakers. So that was a very quick overview of 7 different topics that we're presenting towards harmonization activity within the protection systems aspects of the promotion project. Of course, this is only a very brief piece of information that I've presented on each topic, and there's much more details, of course, and these can be found in the harmonization fact sheets, which are available in our promotion deliverables. These are in promotion deliverable D11.2, which is linked below. Also in our academic publications, and where already published in associated guidelines, recommended practices and standards, although there's not very many things from this which has been published yet, as it's quite newly contributed to harmonisation. In conclusion then, within the promotion project, we've presented a wide range of HVDC protection system related activities, and some of these have led to proposals for harmonisation, or indeed harmonisation activity. Within the work that I presented today, then there's been several contributions. 7 activities have contributed to CGRE working groups, 4 activities to IEC working groups or technical committees, and 1 activity to IEEE Standards Association. And as I mentioned, please look towards our promotion deliverable 11.2 in the first instance. If you require more information, please feel free to send me an email. But in addition to these presented contributions, then we also welcome suggestions. If you find somewhere that you think our work would be interesting to submit to contribute to a particular working group, then we're very open to suggestions in this aspect as well. Finally, the work presented today was from various different promotion and technical work packages, work package 4, 6 and 9. So I wanted to acknowledge the contributions to the work from these people who are listed here. That's all for now. Thank you very much for your time.